All right. So let's move on to the next one, and we can wait for Dr. Zhou to check his audio system. So Dr. Shanshi Zhou is a senior research scientist at Shanghai Astronomical Observatory of China Academy of Science. She has been working on precise orbit determination and time synchronization for BDS satellites, as well as Beidou coordinate system realization and maintenance. So today her topic is the BDCS, the BDS coordinate system maintenance and realization. Please join me to welcome Dr. Zhou. Dr. Zhou, could you share your screen?
Okay. So I will begin my talk. And firstly, good morning, good afternoon, and good evening, everyone. Thank you for inviting us to make this presentation. Professor Hu is unable to attend this meeting due to his work, so I will do this presentation on behalf of him and our work team. Firstly, I will go through the BDCS background briefly, and then some details about the latest BDCS release will be shown in the second part. Since last release, we adopted several methods to assess BDCS accuracy, which are shown in the third part. In the first part, I will give some initial results about BDCS maintenance using only BDS data. So first, since July 2020, BDS have provided various PNT services. Both BDS service and the compatibility and interoperability with other national navigation system require high accuracy realization and the maintenance of BDCS. To meet the accuracy requirements, satellite geodesy techniques are used for coordinate estimation of BDS monitoring station and alignment to the ITRF. For the BDCS realization and maintenance has experienced several stages. BDCS first realization using 4 joint GPS tracking campaigns, including BDS and IGS station. The first campaign was carried out at the beginning of BDS2 service, and the station by station method was adopted, which lasted for about 2 years. The last 3 campaigns were implemented using campaign mode. The first realization of BDS is aligned to ITRF 2014 with accuracy better than 1 centimeter. Considering that BDS3 service have higher accuracy requirement for spatial data, the following strategy is adopted for BDCS update and maintenance. Daily network solutions with loose constraint obtained by estimating GNSS satellite orbital parameters and station coordinates, and then aligned to ITRF. Updating station coordinates when the difference between estimated value and the current value when existing a certain threshold. Currently, it's set to be 3 centimeter. This data processing is carried out annually. BDCS last release 2019 version 1 aligned to ITRF 2014 with accuracy better than 1 centimeter. In the second part, I will show some details about latest released version of BDCS. This slide shows the data processing strategy for BDCS 2019. More than 120 station continuous GNSS tracking data is used, including IGS Global Distributed Station and Chinese regional stations. Daily network solutions with loose constraint obtained by estimating GNSS satellite orbital parameters and station coordinates. Aligning to ITRF by minimal constraint IGS station coordinates in ITRF 2014. Observations span the first 3 months of 2019. The release file of BDCS can be downloaded from BDS website. This picture shows the station distribution. Station coordinates are estimated together with satellite orbital parameters and solar radiation pressure models, tropospheric delay, phase ambiguity, and satellite and station clock offsets. Also, IGS cellular antenna and IGS station coordinates in ITRF 2014 are also adopted as inputs for data processing. IGS core station coordinates in ITRF 2014 are constrained to align BDCS to ITRF. These two pictures shows the coordinate difference between BDCS and the ITRF 2014. BJFI station coordinates time series are shown on the left. On the right, coordinate difference of 31 unconstrained IGS stations are shown in 3 directions. According to the comparison, the difference between BDCS 2019 and the ITRF is better than 1 centimeter. To assess the alignment accuracy, the transformation parameters are estimated using this 31 unconstrained IGS station. The left picture shows the unconstrained station distribution, and the transformation parameters show that BDCS alignment accuracy is about 2 millimeter. In this part, since last BDCS released, the same strategy is adopted to monitoring station coordinates variation. In this part, several methods are adopted to assess the accuracy of BDCS maintenance. So here we adopted 5 methods to assess the accuracy of BDCS maintenance. First, we compare the co-located station coordinates time series to assess the consistency of our daily solutions. Then station coordinates repeatability is calculated. Then although the observation time span is not long enough, the station velocities are also estimated and compared with ITRF. Daily transformation parameters time series are also adopted to evaluate BDCS maintenance accuracy. At last, broadcast ephemeris and princess orbit products are compared to assess the BDCS transfer accuracy. This slide shows the co-located station coordinates time series. In the left picture, the coordinates time series of 4 co-located stations in Beijing area are shown. The black points represent IGS daily solutions, and the other 4 color points represent BDCS daily solution. In the red picture, the coordinate time series of 4 co-located stations in the North China are shown. From this comparison, apparent trend shows in horizontal and vertical component clearly. And besides, the co-located station coordinate variation show very good consistency. These two pictures show the coordinate repeatability for IGS and BDS station in our solution. The repeatability in east and north directions are about 2 millimeter, both for IGS and BDS station. In the up direction, the repeatability of IGS station is better than BDS station. We think that this may be because many of BDS station were built on the top of new buildings, and we adopt about 1 year state to calculate this repeatability. So we think maybe the housing settlement may impact the repeatability calculation. In this slide, we also using this more than 1 year's data. We try to estimate the linear variation of each station and compare it with ITRF and IGS solution. The red table shows the Beijing area station velocity comparisons. The first two lines labeled SHAO are our fitting results. The third line labeled IGS, which is fitted using IGS daily solutions. And the last two lines show the velocity solutions in ITRF and IGB14 solutions. The comparison shows that the difference between our solutions and the ITRF is about 2 millimeter per year in horizontal direction and 3 millimeter per year in vertical direction. In left picture, the velocity difference are compared and the results are the same. Also, we show the velocity field comparison in the red map. In this slide, daily solution transformation parameters time series are shown in this picture. After aligning to ITRF using IGS core stations, the transformation parameters are estimated using unconstrained IGS station to evaluate our alignment accuracy. According to the average and the standard variation of these transformation parameters, the alignment accuracy consistent with BDCS 2019. And furthermore, it indicates that BDCS maintains continuously and stability. At last, broadcast ephemeris and princess orbit are adopted to evaluate BDCS transfer accuracy. Two comparisons are carried out. For the orbit comparison, transformation parameters are calculated between broadcast and princess orbits. And for the station coordinates comparison, transformation parameters between station coordinates of PPP using broadcast and princess products are calculated. GFZ princess orbit products and broadcast ephemeris are used here, and about 100 and 30 global distributed MGX stations are also used for PPP processing. This slide shows the translation parameters for BDS3, Galileo, and the GPS. Compare these three systems. It shows that annual systematic error found in Z translation for BDS3, showing the manufacturer and orbit plane dependent characteristics, and random errors dominating for the GPS and Galileo. Results from orbit and coordinate comparison are at the same level. For the rotation parameters comparisons, systematic errors in rotation are also found in BDS3 due to the increasing error of EOP predictions within 1 week, and resulting in positioning error up to 25 centimeter. And for the scale parameters, no systematic errors in scale found in 3 systems, but negative bias found between orbit and PPP comparisons due to the highly correlated between clock offsets and the scale factor due to the during the PPP processing. And in the for the first pass, we give a very initial result about BDCS maintenance using only BDS data. The strategy is quite the same as before, but only we use the BDS data. The data span is from 2019 October and to the 2020 March, and we use about 200 global stations, including IGS station and BDS stations. The accuracy for the accuracy evaluation method, we take 2 methods. One is consistency analysis of the BDS station coordinates and translation parameters. In this slide, we show the repeatability and the comparison of coordinates.
Hey, Dr. Zhou, we are behind the schedule. Sorry for interruption.
Oh,
so you can,
okay.
Could you go to the conclusion soon? All right. Thank you.
Okay, I go to the conclusion that BDCS in high accuracy alignment with ITRF, and although BDS3 broadcast orbit are constrained only by several regional stations, TRF accessible via BDS3 broadcast orbit still coincide with ITRF at centimeter level. Nonlinear characteristic evident in BDS station coordinate time series need further modeling, and only using BDS data from global tracking station coordinates can be estimated accurately, and BDCS can be aligned to ITRF at millimeter. And finally, joint force from GNSS community are mostly welcome to improve BDCS. Okay, thank you.
Okay, thank you, Dr. Zhou. I think this is a great talk. I'm happy to see the Chinese improvement on the coordinated reference frame. So we have no time for the questions of Dr. Zhou. Now we have to move on to our final speaker,